Welcome, class. In this video I want to discuss transformations of function sums, since that's the issue that a lot of us had some trouble with in class. So let's look at these. So if I have f of x equals x squared and g of x is x minus 2 squared minus 1. So obviously g of x is a transformed version of f of x. And if I want to graph f of x, I know that this is the parabola that goes through the point 1, 1, and then 2, 4. So it goes up like that on that side, and then it goes to the point negative 1, and 2, negative 2, 4 on this side. So it's a U-shaped graph. It's a little more pointy down here than it should be, but this is the general shape. This is the U-shaped parent graph. So let me change to a different color, for maybe blue or something. To graph the g of x function. So if g of x is x minus 2 squared minus 1, this minus 2 means that I'm going to the right 2, and this minus 1 means I'm going down 1. Okay, so let me change colors. Okay. So x minus 2 means I'm going to the right 2, and then minus 1 means I'm going down 1. So it's going to be the same graph, but like this. So it's the same shape, just shifted to the right 2 and down 1. Okay. So that's all there is to it. There's not like a lot of rocket science that happens here. We should look at some points. So the point 0, 0 goes to the point, so it goes down 1 to the right 2. The point 1, 1 will go down 1 to the right 2, which is right there. The point 1, negative 1 will go down 1 to the right 2, which is right there. So there's a pretty good idea of what your graph looks like, okay? It doesn't have to be perfect because we're hand drawing it, but it should have some semblance of accuracy to it, okay? Alright, let's look at another one. Let's let h of x be let's do absolute value of x. So then g of x, well, we already used g of x. Let this be j of x. So let j of x be the absolute value of x, let's do negative x, minus 1 plus 1. Okay, so this one is a little bit of an unusual one, because I have a negative on the inside here. Now, in order to properly do this transformation, this negative needs to be over the entire inside. So I can factor out a negative here to make this negative x plus 1 plus 1. So all I did here was take a negative and factor it out, okay? So I have a negative on the inside. What does that do? Well, the negative on the inside is going to reflect it left and right. It turns out with absolute value, that's not really going to do anything, but we'll graph it the same either way. So then I have plus 1. This means that I'm going to the left 1. And then I have a plus 1 here. This means that I'm going up 1. So the original absolute value function, let's see, original absolute value function, let's do that in blue. Oh, well, I already got blue. Let's do magenta. Is going to be the V-shaped graph going off with a slope of 1 like this. Okay, so there's the original absolute value function. If I want the new absolute value function, it's going to be flipped sideways, but if you notice that with the absolute value function, if you flip it sideways, because it's an even function, it really doesn't do anything, because this this side right here is going to go off on this side, and this side is going to go over to this side, and nothing changes about it. Okay. So, but we do need to go left 1 and up 1. So let me change my colors to red. We haven't had red yet. So I'm going to go, starting at the origin, going to go to the left 1, up 1. My new coordinate goes there. And then another point I have is 1, 1. It's going to go to the left 1, up 1. Another point I have here on my original graph is negative 1, 1. It's going to go to the left 1, up 1. And there is my new function. Assuming that I can actually draw straight, which apparently I have trouble doing. Okay. Let's look at one more. Let me clear off the board because it's getting kind of messy. Okay, and let's put our coordinate plane over here. Alright, so let's look at f of x equals x cubed. Now I want to do a g of x that's going to equal negative x minus 1 cubed plus 2. So the negative here is going to make sure that my graph flips. So let's plot my parent function, and I'll do that in black so we know that it's the parent function. So my parent function with the cube function goes through the origin. It also goes through negative 1, negative 1, and it goes through 1, 1. And it's going to go off like so, and then like so. So that's my parent graph. But let's look at my transform graph. So the transform graph is going to be moved to the right 1. So this tells us we're going to be moving to the right 1. And this tells me I'm going to be moved up 2. And the negative in front, this time it is going to actually do something because the negative, it's not just an even function that soaks up the negative on the inside. So the negative, in this case, is going to be affecting my y's. So all of my y's will change. All my y's will change signs. Okay. So looking at these points, the point 0, 0 is going to just be moved to the right 1 and up 2. So it's going to be right there. The point 1, 1 is going to be moved to the right 1, up 2. And that's at 3. But since my y's are going to get negated, that's going to be down here. Oh, you know what? That should come down here because that's at 2, so it should be at negative 2 because the y's get negated. Okay, so right here that's not true. The y should get negated, so the positive 2 becomes a negative 2. And then my other point right here, I have the point negative 1, negative 1 is going to go to the right 1, up 2. So that's right here at 0, 1, but my y gets negated, so it's going to go right here. So my function is going to do this stuff right there. Okay. So there's 3 good examples. Hopefully that gives you a good idea of what's going on here and how to graph these. If not, of course you can get in touch with me, but I think this gives a decent idea of what's going on.